And I should aim for 45 minutes, no?
Yes,
So that
ma'am.
then there's 15
Yes,
minutes
ma'am.
for
Yes.
Q&A. Yeah, I'll aim for that.
Good afternoon, everyone, and thank you for joining in. On behalf of the Prime Minister's Museum and Library Society and Nehru Planetarium, I welcome you all in the celebration of World Space Week 2023. The World Space Week is an international celebration of science and technology and their contribution to the betterment of humans. World Space Week aimed to provide a unique, live-ranging space outreach and education and educate people around the world about the benefit that we receive in the form from space. This year, the theme of the celebration is space and entrepreneurship, and the theme has a lot of jingle in it. And if we talk about today's era is all about science, technology, and a lot of new developments are taking place. To celebrate this week, Planetarium is having various online activities for space enthusiasts. Today we have with us Dr. Priya Hasan, Assistant Professor, Physics Department, Maulana Azad, National Urdu University, who will be talking on the commercial space age. First of all, thank you so much, ma'am, for always accepting our invitation and coming to our platform to share your knowledge and experience. Let me quickly share about Dr. Priya Hassan. Growing in Mumbai, Priya went to USSR to pursue her integrated master's in physics at Moscow State University, Russia. She did her PhD in astronomy from Osmania University, Hyderabad in 2004. She did an Indo-French postdoctoral research project at Inter-University Center for Astronomy and Astrophysics, uh, Pune, India, 2004 to 2006, and worked as a DST women scientist in Osmania University in the period of 2006 to 2009. She taught at Mukafn Jha College of Engineering and Technology, Hyderabad, from 2010 to 2015, and joined Maulana Azad National Urdu University in Hyderabad from 2015 to till now. First of all, thank you so much, ma'am, for coming to our platform again and accepting our invitation to talk on this topic. So,
Yeah. I think I had a problem with that, but I'm back. And
yeah.
yeah. So hello, everyone. And thank you very much. Thanks for Prerna for calling me. And this time, the theme which we have for World Space Week is on space and entrepreneurship. And can you see my screen fine?
Yes, ma'am. We can
Okay,
see.
is it fine? Okay, yeah. So thanks, Prerna. Thanks for having me. And today, actually, it's a slightly non-sciencey
Yes.
topic which we are going to talk about today because it's space and entrepreneurship. But I thought that it was something very interesting because there is a major change which is happening in the way space science is being done, and it is. I think it opens out many new avenues for students, especially who are interested in space as well as who are interested in some kind of entrepreneurship or some kind of what can they exactly do with the passion they have for space, because often when you talk to a lot of youngsters, many of them are very interested in doing something about space and things like that, and with this you can actually see what is it that you can actually do. So I've titled it as the commercial space age is here, and let's go ahead. So here are listings by three quite different people. You have a saying by Elon Musk saying that sooner or later we must expand life beyond our little blue mud ball or go extinct. Then there is one by Carl Sagan, which says all civilizations become either spacefaring or extinct. And then the third one is by Stephen Hawking, who says that I don't think the human race will survive the next 1,000 years unless we spread into space. So, though all these three people are so very different, but definitely the message they are conveying to us is what is important, and that is that the space age is here, right? And this time it's there in a very different way, in the sense this is a way in which there are many new avenues open to people and many kinds of things you could be doing about space, right? So first of all, let us start off with a basic definition of space. So one of the definitions given by Carmen in 1960 was that space is when you go above 100 kilometers from the from sea level. Then that's what we call space. Now Carmen actually tried to give a physical definition to why did he say that, because see, typically when you have aeroplanes, you can see on the right hand side Typically, aeroplanes, they go at a height of about 60 to 20 kilometers. That's all they do. And it cannot go much higher up because, for the simple reason that as you go up, the atmosphere becomes less and less dense. Now, we need the density of the atmosphere because the lift, the aerodynamic lift, which planes get from their wings, is basically coming from the air. And the thinner the air, you will have a more difficulty in having the lift. Now, another force which aeroplanes can depend upon, it is the centrifugal force, right? What is that? That if you have mv squared by r, you have an object going out at a large velocity, right? You have this outward force which works on the thing, which actually keeps it up, right? So what happens is that typically, if you're within 100 kilometers, you have aerial activity, you can have all kinds of air sports, you can have all kinds of things which are basically dependent on the air. But then once you go above that, then you have to actually fall back on high speed. That means if you have a high speed, that's when you can actually, you can actually have the lift which you need. And therefore, this was the basic definition that Carmen gave for this thing. But obviously, there are many people who think differently, who think like there are some who think that 80 kilometers is enough to define space, while it could vary. So 100 kilometers is a kind of a, this thing. Now, initially, space, right? This was only accessible to government agencies in all countries. In the US, you had NASA, Japan, you have JAXA, in India, we have ISRO, the Russians have Roscosmos, so there was the Soviet space, this thing. And the thing is that it was only considered to be government property. Now, NASA was also promoted as a body which was basically meant for the benefit of all mankind. And even the Indian Space Agency, it's very interesting to know that immediately after independence, when Vikram Sarabhai was promoting the ISRO, or Indian Space Research Organization, there was a lot of protest against it because it was believed that India was, a poor country. They had to come up from colonialism, and that was not the right thing that we should be spending our money on the space program. But Vikram Sarabhai very well justified it by saying that specifically because of the state of the country, we do need a space program because that will be very important for the development of the country. And I think he was right to a very strong extent, as we go on to see that the space program has actually contributed a lot to the development of the country. Now, typically, there were at least 16 space agencies, even more of them, which existed. You had NASA, you have Roscosmos, China has their own, the Europeans have the European Space Agency. And before the EU was set up, each individual European country also had their own space agencies, the Italians, the French, etc. You had Japan, which has JAXA, Australia has this, and a whole bunch of other countries had their own space programs, right? And these were the space listing. Now, if, for example, the most popular space program, which is that of NASA of the US, they basically had what was called their space shuttle program. Now, the space shuttle program was something very, very important to their this thing. Before this, they also had the Apollo program, which was the moon. They had Skylab, they had the Soyuz programs. And the space shuttle was typically one of a kind because it actually comprised of an orbiter, which was launched with two reusable solid boosters, a disposable external tank, and it could actually carry up to 8 astronauts, okay? A load of about 23,000 kgs, and would actually, the interesting part about this, which I'm going to show you, is it would actually take off and it could land like a glider, right? So here I have a video, which I will show you of typically how it actually moved. So you have, when it did its re-entry, right? The launch was like a typical launch, but when it did its re-entry, then at that point of time, it actually, landed like an aeroplane would land, right? And I am just waiting for this thing. Yeah, okay. So you can see that the landing of it, which is very interesting. You actually have it landing just like an aeroplane. And because of this, it was reusable. You could use it as often as you want. You could actually see the earlier programs. What would happen is that you launch a rocket and then the rest of it falls into the ocean, right? Because you send it through the East Coast, it lands in the ocean, you retrieve it, and then only after that you can actually have your next launch. But with the space shuttle, what happened is, since it landed in like an literally like an aeroplane, it took off like a rocket, but it landed like an aeroplane. This is a landing at the Kennedy Space Center, which is in Florida. You can see how beautifully it lands. And once it's land, it's actually ready for the next launch, right? And that's what made it a very powerful, engine to actually use for launching, right? So this is one which actually shows you the landing of the space shuttle. Uh, so the space shuttle, like I showed you, this was, you have the orbiter, this was your rocket boosters, these two, tanks over here, and this was the additional external tank. So what happens is when it launched, right? So you actually, when it launched, and the only thing was this external tank, which would actually it burnt up in the atmosphere after each launch. But the rest of it, the solid rocket boosters, etc., they were immediately retrieved. So you'd actually fall into the ocean, you retrieve it and you get it back. And the main orbiter, which we just saw, it would actually land like an aeroplane and you could keep it ready for the next launch. So the shuttle was a very unique program which NASA had, which was the only wing crewed program. And various things it launched is, for example, one is the International Space Station, you have the Hubble Space Telescope, and a lot of satellites, etc., which were actually launched with the shuttle, right? But then, unfortunately, what happened in 1986? So the shuttle started in 81, but in 96 there was a disaster, the Challenger disaster, where you actually had seven crew. You can see the crew over there, and the disaster actually happened at liftoff. So at liftoff itself, 73 seconds after the flight, it actually exploded, and all the seven crew members were, burnt at that time. After that, there was another big disaster which happened again with the space shuttle, which was the Columbia one, where Kalpana Chawla was also there. In this case, the problem happened at the point of re-entry, right? So the launch took place and experiments were conducted as planned. But then what happened is that by the time it came in for the re-entry, there was a problem with the insulation, and due to which the thing actually burnt on re-entry. And therefore, it was actually, there was a big probe made. This was obviously something to be very worried about. So there was a big probe made about this as to what is it that is actually happening. And because of this, there was a decision made that the shuttle program has to come to an end. And therefore, they decided to retire it in 2010 after it finished the assembly of the International Space Station. Right? They avoided crewed missions and then they just did this thing. So the entire retirement of the shuttle fleet actually took place in 2011, and all the different this thing, there was Discovery, Endeavour, Atlantis, etc. These were all sent to different locations. So now they are all in exhibit in the US. You can actually see the Enterprise, which is in New York in the Air and Space Museum. There's Discovery, which is in the Smithsonian National Air and Space Museum, Atlantis, which is in Florida, and Endeavour, which is there at LA in California. So that's when in 2011, the space shuttle actually retired. And then gradually, there was, it was obviously necessary to think up a new program. But obviously, these kind of programs take a lot of effort in R&D, as well as a lot of effort in terms of experimentation. The kind of launches you would have, and how do you actually plan it and do it so that the whole thing, is smooth and successful. And therefore, at that time, NASA actually decided on a paradigm shift. And this paradigm shift was basically that instead of NASA doing it all on their own, they decided that they should outsource the space program, right? So if they outsource the space program, then in that case, they could actually pay some other private companies to actually conduct the things they could do. So that they thought this would be financially more feasible because the losses would not have to be borne by NASA. And therefore, we have the three popular contenders we all know. There's Elon Musk from SpaceX, there's Richard Branson from Virgin Group, and Jeff Bezos from Amazon. These were the three main contenders who actually were the big ones who then got on to, provide the things that NASA actually wanted, right, in the terms of private this thing. And gradually, it was discovered that not just NASA, but various things were being outsourced to private companies. not just the launch. It could be the launch, it could be various components which are part of satellites or of the space mission. And it basically, many space agencies started outsourcing these contracts to other companies. And gradually, you had a whole bunch of space companies which came up all over the world, okay? Not just in the US, in Europe, in India, in all countries, all over the world, in China. And typically, the startup space companies, they attracted almost a $15.4 billion industry in 2021. It actually doubled in, um, and over 10 times more is what is expected in 2024. So suddenly now you have this big boom of the space industry which is taking place. Now let's start off with, now some of this is obviously a little science fictiony, but let's first of all start off with the concrete reasons why people are going out to space and what are they actually doing. So let's first of all go with the satellite industry. Most of you all may be aware of Starlink. And Starlink, basically, the idea behind this is to provide internet via satellite networks, right? Instead of having, individual, towers, etc. The idea was, what if you actually have satellites which will provide internet, and with that you can actually launch various communication satellites. And there are a whole bunch of private companies who would like to do that, right? So by 2019, you had actually 32 firms which actually had plans to launch total of 13,500 communication satellites to low Earth orbits. Okay. And there were a large number of proposed LEOs, are low Earth orbits. This is typically 400, 500 kilometers above the surface, right? And in 2018, the US Federal Communications Commission actually approved the deployment of the most popular ones are the Starlink satellites, which were actually planned by, which are basically done by SpaceX. And they have orbits which range from 550 to 1,325 kilometers. And the idea was that SpaceX, which provide these satellites, which would basically be providing internet all through the Earth, right? To all remote parts of the Earth and everywhere, right, where it is required, right? Now, what is the idea in basically doing this? The idea is that at present, the communication satellites which we have, these are what are called at geostationary orbits. What is a geostationary orbit? A geostationary orbit is if you have a satellite moving with a period, exactly the period of rotation of the Earth, then you can actually calculate that the height of your satellite has to be about 35,786 kilometers, 36,000. So most communication satellites at present are at a height of 36,000. In this, what happens is they will provide communication to a fixed point on the Earth, right? For a fixed point on the Earth, you have this communication satellite which will do the job. And there is what is called latency. What is latency? That supposing if I send a signal to the satellite, right, and the satellite sends a reply, the signal, the going and coming, will take a certain amount of time because it has to cover a distance of 36,000 kilometers, right? And therefore, if you actually had online streaming or gaming or video calls, which you are using through the internet, those kind of applications cannot be done with a link of this kind, which is at a distance of 36,000 kilometers. You cannot do that. And therefore, what happened is that Starlink came up with the idea is if you have not one, but you have all set thousands of satellites which are going around the Earth at a low height, at a height of about 550 kilometers, then at all points of time, you will always have some satellite which will be above your location, right? They are not geostationary. Like I said, geostationary means, for example, for the city you belong to, it is just above your thing. This needed be that because instead of one satellite, you have thousands of satellites which are at this height of 550 kilometers, so that at any point of time, you will have some satellite to the other, which is up there, which can actually relay your signal. Now, if you have such a thing at 550 kilometers, then the signal can be passed very fast. And in 20 milliseconds or in 600 milliseconds, you can actually have the latency or the interchange of the command. And therefore, in that case, your internet would be of good speeds and of the kind you require. And that's why SpaceX and a whole bunch of companies came up with this idea that you need to have these low Earth orbits, but The problem is it cannot be one satellite. It has to be thousands of satellites so that they can do the job, right? Because otherwise, you will not be able to get your this thing. Now, not just SpaceX, like I mentioned, OneWeb is another company. They also planned a say, fleet of almost 50,000 satellites, but they went bankrupt after launching 74. But they're still on. Amazon ran the Project Kuiper. They already launched a whole set of satellites in low Earth orbits, but then they're still continuing. There are Chinese companies, and there are a whole bunch of private companies who are actually launching these communication satellites at low Earth orbits to provide these internet facilities. Now, this is a typical launch of SpaceX. What they do is that these satellites are small in size, and therefore, this is basically showing you a launch of 60 satellites, right? And you can actually have a launch of six, they do it at a batch of 60 satellites at one point, and they will actually be launched, right? Now, in India, also, what is happening? In India, SpaceX would, so actually, SpaceX will give you a whole web of satellites all over the earth, right? But at present, it's not yet available in India because there's some regulatory hurdle. The problem is this comes under the Indian Telegraph Act and the Indian Wireless Telegraphy Act, and they are basically trying to check about certain parameters. But I'm sure nothing is going to stop Elon Musk from having Starlink in India because India is a very, very big market. And definitely in a short while, they will come into the market. And they are giving speeds which range from about 50 Mbps to about 150 Mbps, though they actually plan to go up to 300 Mbps. Now, there are a whole set of other kind of space satellites also, which people are interested in making. Some of them are what are called CubeSats. Many of you all must have heard about them. There are nanosats, there are CubeSats. These are small. This CubeSat, you can see, is a very small this thing, but it can be very effectively used for communications, for remote sensing, for navigation. These can work as drones. They can also work for very accurate GPS. For example, there are a whole bunch of apps which we use for which we need very accurate GPS and giving you very good mapping, temperature mapping, soil mapping, all kinds of mapping. And therefore, there are a whole bunch of companies whose job is basically just to make these CubeSats, these nanosats, which can be used for these various purposes, right? And like I said, there are what are called nanosats. And like I said, these satellites also have a whole bunch of uses. The advantage is that the launch is lower cost because they don't weigh much. The cost basically depends on the weight. And therefore, there are a whole bunch of small businesses which are actually producing nanosatellites, which can be actually piggybacked on some mission, right? So on some existing mission, you can actually piggyback your nanosatellites and send your listings, right? So there's a whole satellite industry, like I mentioned, not just communication, but remote sensing, GPS, all kinds of weather profiling, soil profiling, all kinds of things which are being done by various companies. And these companies are basically providing services to various organizations. Some of them are government organizations, some are private organizations. And based on that, they actually make their business. And there are a whole bunch of them, right? Now, this is slightly science fiction-y, where some of these companies are actually also looking about making of space bases and habitats, colonization of new planets, expansion of space. But these things, this looks very science fiction-y. Like at some point, it was even science fiction to be even landing on the moon, right? People thought, or even flying was considered to be something very impossible. But in today's time, we know how normal that kind of a thing is. So similarly, these things, though it looks very futuristic, but these are things which are going to come up in this thing, and there are a whole bunch of companies which are trying to build up technology for this. There's also happening in the industry also about space weapons, right? It's obviously would always be very beneficial for a country to actually have space weapons, right? And these space weapons could actually be used for various purposes, and they could be playing a very important role, right, in in this thing. And there, and obviously, we'll come to that later on. There are what are called the international space laws. As per the international space laws, you're not supposed to have any kind of weapons out in space. But obviously, there are a whole bunch of countries, which includes America, China, Russia, and many others who are also actually building up these different kinds of, space weapons, right? Another now we'll come back to realistic. So that was science fictiony. But let's go back to the realistic case. It's also very important as for to be monitoring space weather, right? Many of them all are aware of the Aditya L1 mission, which was recently launched, which is basically to monitor the sun. And the basic idea in this is that we need to monitor the sun. We need to monitor the slora Perez, the coronal activity, the magnetic field, because that very strongly affects communication on the Earth, right? And therefore, if you have prediction or warning of various kind of weather phenomena in space, right, they would be very important for us to not only monitor activities on the Earth, but also, for example, if we want to monitor activities on Mars or the Moon, etc., we definitely need to monitor space weather. So essentially, that is what Aditya L1 is also one of the important agendas on Aditya L1's program is exactly that, is that to monitor the space weather and see how is it, how is the activity of the sun affecting the activity in and around the Earth, right? Now let's come up with something very, very important, which is the International Space Station, right? So it was a long time ago realized that we need to have a presence in space, right? But often these space missions, many of them are very expensive, and therefore often you have a consortium of countries which get together to actually do the space missions, right? And therefore the International Space Mission was set up by a consortium of countries, essentially the USA and Russia, and a whole bunch of other countries, even JAXA, the Japanese, etc. And they decided that let's have an outpost in space which is at a height of about 400 kilometers, right? And this was launched in 1998. And the idea was this was our kind of outpost in space. And with this, what one can do is that you can do various scientific engineering activities. Okay, yeah. So 15 countries were part of it, and it's the size of a football field, and there are various components added on by different countries. Basically, the idea is to prepare us for the space age, right? So the space station, you have astronauts there, you're checking on conditions out in space, on how to actually doing experiments in space so that future phase space missions are planned, and various kind of things like that. But the problem with the International Space Station is that since the time it has been launched, it is manned, right? You have to have crew on the space station. So constantly people have to be sent to and got back from the space station, which also means that you have to send supplies and you've got to constantly have things coming and going, right? So the important thing was that till a certain stage, this was being done by the space shuttle as well as the Russians, right? Essentially. But then after like I told you about the space shuttle program, when the space shuttle program retired, then the Americans did not have any other option. And therefore, what they decided is they decided to give ISS contracts. That means they decided to outsource this to private companies, and private companies could give their tenders, for what is it that they can do for the ISS to actually send not only crewed mission but also supplies to the International Space Station. So as for that, there is a pact between essentially five space agencies, which is NASA, Russia's Roscosmos, Japan's JAXA, Europe's ESA, and Canada's CSA, Canadian Space Agency. Now, all these three have a certain schedule as per which they have to actually send crew as well as material over there. So NASA, like I told you, decided to go in for privatization. So they put up these ISS contracts, and companies could offer to actually do this. So SpaceX actually was amongst the first to do that, as well as Boeing, Starliner. And many of you all have actually heard about SpaceX Dragon. Now, SpaceX spent a lot of money and lots of effort in doing their R&D, the research and development, to actually do this thing, right? Because you have to launch this stuff. Essentially, in the beginning, it was being done more for supplies. The Russians were being used for the manned missions. And then gradually, SpaceX actually started doing it even for the crew, of sending crew. So what happens is SpaceX and NASA, they inked this deal. Deal was signed in 2014, and it basically meant 6 astronaut launches. It was valued at $2.6 billion, and so what happened is you had a crewed demonstration mission, which marked the first astronaut launch. It went out in 2020. And after that, you have a whole lot of missions which have taken place, so much that they have actually extended the partnership with SpaceX till 2030. And so now there's another, it's nearly $5 billion, 14 fully operational astronaut missions, which NASA has signed up with SpaceX, right, to have these launches. Yeah. So this is the Falcon X rocket, which was designed by SpaceX. And this is the liftoff, which is taking place at the Kennedy Space Center in Florida. Okay, 1 minute. I think this is this thing. The interesting thing about this, if you remember the space shuttle went off like a rocket but landed like a aeroplane. In this one, what SpaceX actually did with the Falcon X rocket was even more beautiful. Uh, I 1 minute. This is actually a video, but I don't know why it's not playing. Or here it'll play. Maybe yeah. So this is the Falcon 9 rocket, and I'm just going to show you. This is the launch of the Falcon 9 rocket. And the interesting thing about this is it launches and it actually comes back exactly to the place where it liftoff from, right? That is the unique capability of the Falcon 9 rocket, right? So I'll repeat that this one is not coming, but I'll try this, right? And you can actually see that you have this thing getting launched. And so I don't know why this is not working. Maybe I can just exit and come back again. Okay. I'll just try doing it again. No, it's not. I'll just see if I can do it again. But if you can't do it, no problem. You can always, very interesting. You actually launch it and it comes and sits back exactly where it went off from. So SpaceX has already had 269 launches, of which they've had 269. Total landings have been 231, and total reflights have been 203. So SpaceX has a very good standing on it. Now, Boeing was the other competing company. They also signed a contract with their spacecraft, which is called Starliner, and they actually had its inaugural crewed mission in July 23. They also designed the capsule to make airbag cushioning landings, and they are also the other competing company other than SpaceX who's actually doing these missions, right? Now, while all this happened, like I mentioned, is that the ISS was launched in 1998. So it was now realized gradually that it is getting old. And therefore, NASA announced that ISS operations would end in 2030, right? And you would assume that that would, another factor is that basically because of the tensions between Russia and these other countries because of the war in Ukraine, etc. And because it's basically growing old, people decided that it's time to actually retire the ISS. And you would think that, oh, that means end of business for SpaceX and Boeing, etc. But it doesn't. Instead, it means more business. And basically, it means more business because NASA then decided that they should have their own space mission, which should not be shared with any other country, right? Because what happened with the ISS, they were doing it with the Russians, and therefore, when tensions grew between Russia and the US, there was nothing that could be done, and now they decided to do it on their own. So again, they actually put out a proposal where people could actually this thing, and you actually had companies like the Blue Origin of Kent. They have actually signed a contract for 130 million. Nanoracks has signed a contract for 150 million, and they have actually signed this thing, a total 415 million dollar contract to actually build the next space station, which will be purely NASA owned, right? So you can see that it starts off with ISS. It starts off with providing material onto ISS, crew onto ISS. But along with that, now the future would be the American space station. And then when that comes in, first it is the building of the space station, and then it's again going to be maintaining of the space station. So actually having launches, sending supplies, doing various things. So that's a really big business boom, which is going to still continue, right? And then maybe these other countries also, which were part of the ISS, maybe they will also build their own space stations, right? Which will again mean a lot of new business. Now, another big move, which I'm sure you have heard about, which is the thing about space tourism, right? So, what's happening about space tourism? Now, again, all these very companies, they actually thought that going out to space was a fun thing, and therefore Virgin Galactic, they actually did their first mission, which was in 2021, where Richard Branson and crew members Beck Moses, Sirisha Bantla, all of these, they actually floated in zero gravity, and this was done on the 11th of July in 2021. Okay, they were the first to actually go, but very soon. So this is that time Richard Branson was already 71 years old, right, when he went out there, and he actually went to a height of about 88 kilometers. Now, officially, if you remember, right in the beginning, I told you that the Kármán line is 100 kilometers, but there are many people who believe that even 80 kilometers is as good as space. It actually gives you all the space effects. You can feel zero gravity. All those effects can be felt. And therefore, Virgin Galactic still, in principle, qualifies. And he was the first person to blast off in his own spaceship and do this, right? So I had,
Ma'am, your
yeah.
screen, yeah.
So we had Richard Branson. Is the screen
No,
fine
no,
or no?
no. Your presentation is not coming.
Okay, I should share it again. Okay, 1 second. You lost the presentation totally.
No, just in between, like when you were
Okay,
explaining the
I
things.
think actually somehow I have a feeling that the net today is a little patchy. It's not too good.
Yeah.
Okay, okay. Yeah. So what happens is you had Richard Branson going on, and this 88 kilometers. And then obviously our dear friend, it's not that only he was working at it, everybody else was also onto this business. He actually, in Richard Branson, he actually took even astronaut John Glenn, who was from the Apollo program. At the age of 77, he actually took him on that. So you actually have, this is now Jeff Bezos, who went up with his brother. This is Amazon, the Amazon group. So Jeff and Mark Bezos, the two brothers, and here are they with 18-year-old from Netherlands
Ma'am,
and an
still
82-year-old
presentation is
aviation
not.
pioneer.
Still presentation is not on the screen.
Okay, okay, okay. 1 sec. I'll just try to do it again. Now, can you see my screen? I'm sharing the entire screen. Is it fine now?
No, ma'am, it's not coming. It's not showing us.
You can't see the screen only.
No. No.
Okay, 1 second. The net seems to be okay, but you can see me, right? So I'll okay.
Yes.
I'll just share it again. Okay. Now, can you see? Is it okay now?
No, ma'am, still not coming to me.
It's not there.
Yes, ma'am. Now it's come.
It's there.
Yeah.
Okay, great. Okay. So while you had Richard Branson doing that, you had the Amazon team, that is Jeff and Mark Bezos. These are the two brothers. They actually, what they did is that they took this young boy and they also took this 82-year-old aviation pioneer, Wally Funk. And they actually, so it was, what they did is they took the youngest and the oldest to ever fly in space. And that's the thing which they did in 2021. Now, now they're continuing with their story. So you have a whole bunch of space tourists. This is happening today itself. So you have Virgin Galactic. You have this Pakistani lady who is from Dubai, from the UAE. She'd be the first one, this first space tourist from UAE, along with these other two people. And these three space tourists are going to launch today itself. You're going to have Virgin Galactic, which is going to launch them. This is from Spaceport America in New Mexico. And I think she bought her ticket for $200,000 17 years ago. Now the ticket costs $450,000 for this flight. But this is the lady. Her name is, I know her name till today. I'll just tell you. Itself, right? You can actually buy yourself a ticket and go up on these flights, right? Now, Blue Origin actually also has a capsule which could take you to a height of about 106 kilometers, and the flight lasts for 10 minutes, 10 seconds, and you can actually ticket scale. These are at $1 million. And SpaceX, let's not forget SpaceX, though these guys did it in July. SpaceX in September, in 15th of September 2021, a few months after Richard Branson did it, they actually used Falcon 9 rocket, and what they did was even more. They actually did a four-person crew which spent 3 days in orbit, okay, before splashing down into the Atlantic Ocean, right? So what they did is they had again these people. They had these people who actually went on to their flight. So the SpaceX Dragon and the Inspiration, this was called the Inspiration 4X crew. They orbited the Earth for 3 days at an altitude of 575 kilometers. So this was way higher than the carbon line. Instead, this is way higher even than the Hubble Space Telescope, right? So they went to a height of even higher than that. Now that was so much about America. Let's not forget that there are some more powerful space agencies, especially the Russian space agency, because in principle they were the first ones to actually go out in space. The Sputnik shuttle was the first by them, the first man in space, the first woman in space. All of them were achieved by the Russian space agency. And in Russia itself, there are about 100 companies and more than 250,000 people who are employed already in the space in space companies. The largest company in Russia is called RKK Energy, and there's a satellite developer called ISS Rishnev and NPO Lavochkin. This is for interplanetary probes. And you can actually buy tickets, for example, Cosmocourse. This is a space tourism company. You can buy a ticket for $40 million to actually go for 5 minutes of zero gravity. There's S7 Space, there's Lin Industrial. There are a whole bunch of companies which are actually, they can do a sports tourism thing. There's Start Rocket, which will actually launch 100 CubeSats and do various missions of that kind. So Roscosmos is actually the present day version of the Soviet space agency. And it was formed in 1992, 31 years ago. And here you can see this is a map of successful orbital launches, which were actually done by them in the gap of 2007 to 2011. The blue bars on these are the Russian ones. The red ones are the Chinese. Green is USA, Europe is purple, and this is the other. So you can very well see in this plot that the Russian one, it surpasses all the other contributions from all the other companies. Our Gaganyaan mission, right? Our Gaganyaan mission of sending man, woman slash woman in space. What has actually been done is that they've signed a contract with the Russian company Glavkosmos, as well as RKK Energia, and they are the ones we've actually outsourced the job for the crewed mission, which ISRO is actually planning. And you can see this is the contract which they've signed. And essentially, for the Gaganyaan mission, we are going to have a lot of contribution from the Russian Space Agency in our thing. The European Space Agency is also a very big, powerful space agency, specifically because it is made up of the European Union. So you have 31 countries which are part of the space agency. It's funded by that many countries. Here, since we're from astronomy, I've basically put up a focus of all the different astronomical missions. So there are some very good, brilliant astronomy missions. There was the Planck satellite, the Herschel satellite, the James Webb. It was launched by ESA. It was most of the building was done by NASA, but the launch was done totally by the European Space Agency, who also launched Gaia, as well as there's Euclid and many more space missions. And the ESA is also looking a lot into human robotic exploration, observing of the Earth, satellite navigation, all of these which are things agenda of the European space. And we should definitely not forget in the space race the Chinese space program, right? The Chinese have managed a very powerful space program. Just to bring to your notice that as part of the International Space Station, China was not part of the ISS. And therefore, what China did is that they launched their own space station in 2022, the Tiangong space station. It's the first gathering of two Chinese astronaut crews over there. And you have this is a unique Chinese space mission, which is recently launched, and hence it has really good technology in it. The first spacewalk was done by Chinese astronauts in 2008. The first one, Chinese in space, was sent in 2003. And the Chinese have actually excelled in their space programs, not only at low Earth orbits, but the moon, specifically the far side of the moon, right? No other space agency could go to the far side of the moon like the Chinese have, as well as to Mars. So China is only one amongst the three who can actually have human flight capability. And hopefully, India now after Gaganyaan will also be capable of human flight. That's something that we are heading to. Space hotels, that's again science fiction. If you're going to have space tourism, you'll obviously have to have space hotels, and you can actually do that, right? So there are various hotels being designed and planned. Again, this is slightly science fictiony, but this is something which is happening, right? Another very important thing about space business is asteroid mining, right? Now, asteroid mining is very important. I will actually first talk about what are asteroids. So most of you all know that when the sun formed, it basically formed from a giant molecular cloud, and you have gravitational collapse taking place of the cloud. In the center, you have the sun forming, and then from the protoplanetary disk, you have planets forming, right? And that's exactly how the solar system formed. So you see that the sun is forming in the center, and then you have these different regions from which you have material accreting, from which planets form, right? Now, while this thing happens, the star is born, the sun is born. You can see gradually the planets are formed at various orbits around this young star or the sun. This is an animation. But you can see that while it forms, there's still a whole lot of debris, right? So 5 billion years ago, when the sun solar system formed, you still had a lot of debris which was in and around the solar system. And this debris is exactly what we call asteroids. Okay, they are called asteroids. Now, these asteroids are basically made up of material 5 billion years ago, and a lot of it has very rare earth metals and very interesting chemical composition. And therefore, people came up with this idea of asteroid mining, right? And therefore, it's basically extraction of materials from there. And therefore, people started the thing, for example, with the Hayabusa mission, where they actually tried to send a research mission. And you may be aware of Osiris Rex mission. Recently, just in the last week, they actually got the first samples from an asteroid, where we are actually going to now test those samples to see what is the kind of material available in these asteroids. So Osiris Rex mission, it actually went to a asteroid called Bennu, and it actually went there. It's got back a sample last week back to the Earth for study. Okay. So the idea basically is while the solar system formed, you have asteroids here between the orbits of Mars and Jupiter, and then outside the orbit of Uranus, where you again have a lot of this material, right? Which is the leftover material of the formation of the solar system. And so if you actually look at the solar system, you can see that these are the regions where you do have asteroids. And there are various asteroids. We won't go into the details. But like I told you, what's interesting about them is the chemical composition. And therefore, for example, in January, you had a California based startup, Astroforge, which announced in 2023 that it will lay foundations to be the first commercial company to mine an asteroid. Then there's another asteroid called Rigu, and it is priced at actually 82.73 billion US dollars. And you already have companies and missions which are going there. So I'm going to show you this a very interesting slide. You can actually see asteroids, and there are actually price tags. And if you see this price tag, is it QT? QT is a quadrillion dollars, which is 10 power 15 dollars, right? Which is 1,000 million millions or 1,000 trillion million billion, right? 10 power 15, right? So you can see there are all these known asteroids which we know, and there are actually price tags, right, of what is the price tag for them. So you can see that there are a whole bunch of them which cost quadrillion dollars. And therefore, for example, if you go to this one, which costs 26 quadrillion dollars, you can actually get material worth that much of amount from this thing, right? So asteroid mining is also this thing. I did not put in a slide, but some of you all who may have seen the movie Don't Look Up, right? That was a very brilliant, lovely movie on asteroids. And if you remember in the movie, you had this very big billionaire who's a friend of the president who tells the president, let the asteroid come. We can actually mine it and get all the material from it and get even richer, right? So that is a proposition which is there of actually doing asteroid mining. And what is happening back home? ISRO. ISRO also traditionally, like NASA, was a government-based thing, and they actually, but they started already a business of outsourcing. For example, you had in 2017, they actually launched 104 satellites on a single rocket, and basically they custom launch it for different countries who don't have their own launching facilities, right? So they actually do it along with that. But they also they actually announced a private sector, okay, for ISRO, which was called InSpace. And InSpace is actually a private sector where you can actually have the private sector work going on off this thing. So 24th June, the Union Cabinet actually approved this thing, and they actually started the New Space India Limited, which is a private organization, which is actually doing development with things in launch vehicles as well as in satellites. And along with this, a whole bunch of startups came up in space, even in India, right? Because this is now to cater to ISRO as well as InSpace, as well as private companies which are actually interested in having satellites in space. What are they doing? They are basically building different parts of the satellite. They are building the communication apparatus. They are doing the infrastructure. They are designing it. They are doing all kinds of things. And these are the space tech entrepreneurs, right? So, for example, there's a company called Pixel. And this Pixel company was founded by a very scammer. Then she disappeared in 2019. And they basically they basically imaging satellites so that it provides them the capability of monitoring the Earth 24/7 in real time. Okay, that's the purpose of Pixel. There's also another company called Vesta Space Technology, which is headed by Arun Kumar Sulivan, which is basically on creating small satellite platforms for industry and scholarly users. Okay. Then there is Team Indus, which is a Bangalore-based company, and this was founded in 2010. They actually won the Google Lunar Prize, and they have various investors in them, and they've already raised about $200 million from various investors, and they basically it's a startup company, right? Then there's another space company in Hyderabad called Dhruva Space Private. They actually build up different kinds of payloads so people can actually get their customized payloads built by the company. It's run by Sanjay Srikant Nikanti, and they offer space solutions for different companies, and they would launch their tiny satellites into orbit depending upon their purpose. There's another company called Satellize. It was earlier called Exceed Space. It's now Satellize. And they actually are the first private company in India to actually have a satellite in orbit. Okay, they did this in December 2018 when SpaceX launched their first satellite in space. So you have these people, Chris Nair, Ashar Farhan, who's a personal friend. They actually created the company and they actually built tiny satellites for their customers. So you can see that there is definitely a lot of business in space. There's a lot of things that can be done in space. And therefore, people are now trying to actually formalize even space laws. And the United Nations actually set up what was called the UNUSA, United Nations Office for Outer Space Affairs. And they actually set up laws which are to be signed by countries, by space age organizations. So that is the Outer Space Treaty. Essentially says that space in space or producing any, you cannot use it for the claim of sovereignty. So if you actually hear somebody saying that about talking about selling space on Mars or on the moon or something like that. It's not allowed in principle. You cannot be doing that. It has to be only be used for peaceful purposes. They cannot place nuclear weapons over there. It has to be purely for exploration. There was also the rescue agreement that in case there's an astronaut where there's a security problem or whatever, then rescue of astronauts, return of astronauts, etc., will be something in which everybody will contribute, irrespective of which country the astronaut belongs to. There's also the liability convention. For example, if one or two of the states they launch a space object, okay, and supposing during the launch there is some amount of damage which is caused, then the launching case has to actually pay the compensation for the damage for whatever happened, right, when they did the launch. There's also the registration convention that if you are sending anything out in space, you have to actually register it. So, in principle, that applies, for example, to SpaceX. When SpaceX is sending their Starlink satellites, they have to actually, in advance, inform what are they sending, what are the orbital parameters of the objects they are sending, and what is to be done about it, right? And but that's also the registration thing. There's also the moon agreement, which actually says that to not only to outer space but also to the moon and all celestial bodies, that their environments cannot be disrupted, and the moon and its natural resources are common heritage for mankind, and that an international regime should be established to govern exploitation of the resources, right? Space laws in India have not yet come in place. There's something which is still happening, and it should hopefully come in place very soon. The Astronomical Society, the International Astronomical Union, has actually set up a center, the CPS, the protection of dark sky and quiet sky, because now you see with all these satellites being launched out in space, it's becoming a mess. Not only space debris, but even there are constant new launches which are happening in space, which are obviously very disturbing. And if you can actually see, this is a video I have of one of the Starlink launches. And you can see that when one of the Starlink launches took place from the Earth, you can see that you had this whole trail of satellites, okay, which could be seen from the Earth. Now imagine you are in this great observatory trying to do some astronomical observations. Right now, like I told you, SpaceX launches 60 satellites at a time. So you are at this telescope trying to observe, and suddenly when you're observing, you have this trail coming in of the satellite trail, and they're totally going to mess up all your observations, right? And this is when the launch took place. That time they're at a lower Earth orbit. Gradually they move upwards. But obviously, as we are going to continue to have more and more of these launches, you're going to have disturbances like this, which is really going to spoil astronomy. The dark sky, number one, you will not have a dark sky. And number two, the quality of ground based astronomy observations. Imagine if you have a sky like this and you're actually looking at it. So I have an example. And some of these satellites can be actually observed even in the day. So when the launch took place, you can see these are the satellites and you could actually see it in broad daylight. I'm not going to run this, but you can have a look at it. So typically, if you have a bunch of satellites in your screen, right, if you're observing, you will actually have satellite trails of this kind. So imagine if this was the region you were trying to observe and you have all these satellites which come in, they would be so, so bad. Now, the earlier satellites were not very bright, but these present day satellites, they are brighter than 99% of present objects. And these are going to disturb not only observations in optical light, also in near infrared, in radio, and various bands. And therefore, a lot of effort is being taken by astronomers all over the globe, not only the International Astronomical Union, but various astronomical union, about keeping a some kind of regulations as to how many satellites can you actually allow in the sky and what can be done, because this is the example of the kind of satellites. This is using real data, the kind of satellites which are already there. So they had what is called the satcon 1 and the satcon 2 workshops, as well as the dark and quiet skies 1 and the diet and quiet skies 2. And now the International Astronomical Union has actually set up its center for dark skies, and which is actually supposed to regulate this thing. So typically what is being planned is that we need to raise the awareness about policy making in satellites. And there should be the registration convention where we have all the data of when are the satellites, where are they being launched, so that an astronomer, before he does his observations, he can check whether are there going to be any satellites which will come in his path. And Also, specialized software is also being developed so that if you have these satellites coming in the path, then you can actually block them. You can actually use various software to actually clean your data frames from this thing, right? So I'd like to conclude with this that now we've come to an age where space is now for everybody. The private sector is into it, government sectors are into it, individuals are into it. And now it's not just a place where a few people in science and math or select group of astronauts are actually looking in space. It is now a new frontier over here. Everybody, it's not everybody's business, but everybody's can be doing business over here. And therefore, now we actually need to consider, like I said, the space laws, the regulations, and there has to be a proper build up of how are we going to actually, use space for the benefit of mankind, for the benefit of various industries and things which we would like to use it for. Right. So I will end with that, and I'll be happy to take questions. Yeah. So if there are any questions,
Yes, thank you so much, ma'am, for sharing this like broader perspective of the topic, and also I was very much into it because space law and regulation and policy are such important role to be played if you talk about the privatization in such sector, because space is for everyone, and no special body or any private organization can do anything without any regulation and everything. Also, in presentation, you have mentioned about the Gaganyaan, and also the Russian agencies are paying more role in that. So I just wanted to share that because Nehru Planetarium has Soyuz T10 original space ship module inside our premises. So ISRO has just take it for doing some research related to Gaganyaan mission. So they have took it for some time from Nehru Planetarium
okay.
to do a little bit research about the fabrication and how the things have been used in that. So this little insight I wanted to share with you related to Gaganyaan, as you have
Oh,
mentioned.
that's interesting.
Yes.
That's interesting. Yeah.
So because people are not so happy, because people generally come planetarium to see that. Many of the enthusiasts come to see that spaceship module inside the planetarium. But for a long time, it is with the ISRO. But in ISRO, it is in the right hand because they
But
are
where did you
doing.
get it from? How did you all get it?
Yes, so they must be doing
How did
something
you all
like.
get this module? Where did you get the
So,
spaceship?
ma'am, it was gifted by the Russian space agency when Rakesh Sharma went to space from India. So, as a token of
Okay,
gift,
okay,
yeah.
okay.
So, as a token of gift, so they have given to the government of India, like to the government, and government, because this was the main attraction for space science and astronomy enthusiasts, Nehru Planetarium. So, Indian government have given that spaceship module to Nehru Planetarium so that many more people can get benefited by watching it, and like what is the detail of that space module.
Hmm.
So now we can take
Interesting.
some question. Vidya
Hmm.
wanted to ask, why does China want to double the size of ISS?
See, everybody wants to go big and bigger, right? Though you say space is, for mankind and etc., but it obviously involves a lot of, pride. It's a status symbol if you're a space country. And like I said, that since China was not part of the ISS, therefore, obviously, when they built their own space station, they wanted to build something that's bigger. So I think that's a simple answer is just for it to be big. And then, for example, their space station has a telescope on it also, right? The ISS doesn't have a telescope on it. These guys actually have a telescope on theirs also. So then they actually built up more, there's more stuff on there, this thing. And basically, it's a difference in technology. See, ISS was done in 1998. This is like almost 20 years after that. So obviously, there's a big change in technology. And therefore, like I said, the telescope is there, and you can actually see that there are many more things on their space station. So, yeah.
So, ma'am, even
It's a much more, what do you say, modernized space station compared to the ISS.
modernized, even India is also planning to establish their international space station, as I have read somewhere in the ISRO documentation. So, like, you have any insight about that? Like when the things are in pipeline
Yeah,
or
yeah.
something?
So actually, I told you right that now actually most of these countries want to make their own space station, because the problem was, like I'm saying with ISS, you had the Ukraine war, but it was signed from the very beginning that this thing is going to continue, the cooperation. So that continued. So even Russian, astronauts have been going there, right, from the Russian launch vehicles. So then suddenly, obviously, now countries thought, see, there's a trade-off. If you make it with different countries, then you have lesser liability and lesser expenditure, right? But if you make it on your own, it is your independent thing, but then it's your liability and your expenditure. So it depends upon how you do it. So I think for America, it's fine. It's easy for them to do it. But I don't know whether the ISRO budget would permit it, because the problem is there has to be crew going there. There has to be. So I think this is something which can happen only in the future after Gaganyaan. But first we need
Future.
Gaganyaan, where we actually do
Yes.
crewed missions. We figure out how to do a crewed mission, and only after that can this thing be planned. So this could be for the far future, but not the near future. I think it's not near future.
It's not in the near
It
future,
was
definitely,
something
because
which we can
until and
plan
unless
for,
our
yeah.
crew mission went successfully, then only we need a space station.
That's right. That's right.
So we can take Ishan Pawar. Collaboration between government and
Yeah.
commercial entities is crucial for the success of many space mission. Can you share example of successful public private partnership in space exploration?
Yeah. So what I showed you? What's the ISS one with SpaceX, right? NASA has been doing it with SpaceX with their Dragon X mission. So they have been handling ISS since the time the space shuttle retired 2011. Either things went only by the Russians, or then NASA managed to send it only through SpaceX, and now they're going to do it with Boeing, right? Similarly, even ESA, European Space Agency, the Gaia satellite, which is basically a telescope, that was totally outsourced to a private company, Northern Grumman, and they actually are the ones who built all the stuff for the telescope. So there are many examples of. So NASA has done it, ESA has done it, ISRO is also doing it. What they do is that they outsource certain components, certain aspects. You know, there are many what do you say aspects in the launch, and those are the ones which they outsource. So what these space companies have to do is to excel in a certain thing, which then can be provided. Does Yeah, obviously, I think I told you it was billions of dollars. Vidya kind of, yeah, I can tell you how many. I think I forgot the number, but it's a super large number. I think it's $5 billion or something like that. What NASA is paying SpaceX. Yes, SpaceX is only doing it on payment,
Nothing is
right?
free,
For
actually.
SpaceX, yeah, SpaceX is doing it for money, right?
Yeah.
It is what do you say? It's a contract. So earlier the one was for $2.6 billion, and now it is for $5 billion till 2030. Yeah, yes. So they're doing it just for the money part of it. Okay. Ishan has another question. What potentially plausible, profitable resources extraction opportunities does space exploration offer? So, like I told you, people have already assessed different asteroids based on their chemical composition. What is the cost of these different asteroids? Like I told you, the Osiris Rex mission, which came last week. Last week, it actually came back with some samples from the Bennu asteroid, and they got those samples. And so obviously it is uh, the investment is also large of sending your thing to the asteroid, getting it back. But people think that if it is done in a cost effective manner, it can be profitable, because the simple thing, like lithium, you want lithium batteries for your electric cars, for example, or for various things. We don't have that much of lithium on the earth. So if you have a lithium rich asteroid, there are some of these asteroids which are lithium rich, then you can extract it from that and you'll get it from that source. So it is a question of uh, cost minus the expenditure to do it. So if they can find cost effective methods of actually extracting and getting it back, then yes, it can be profitable. So people have to just figure out how to do that in a profitable way, right?
So, ma'am, is it possible,
uh,
like,
for
if we are
example,
bringing bringing back like back to the earth the asteroid for the mining part, which you have discussed in the presentation, like how much time duration do we need it, like we can preserve that, the duration of time, till what time we can
You say
preserve
for the
that?
flight to and back the asteroid,
Yes, yes.
to and fro from the asteroid.
Yeah.
I think Rex was actually launched, I think, 2, 3 years back. So I'll just check. I think it took about 2, 3 years. I'll just check the date of launch. So Osiris Rex, it was launched in, oh, okay. Oh, it was launched in 2016, but it got it back now in 2023. So it obviously depends
Yeah.
upon where is this asteroid, where is
Where
it
is the
located. So
location
that
and
will,
yeah.
yeah. So that depends on that. And is there a point when it's like coming close to the Earth that you can catch it at that time? Because some of these are very highly
Yeah,
elliptical orbits. So they
elliptical,
could
yeah.
have a point when they are closer to you, and if you do it at that point, maybe it could be this thing. Yeah. But like I mentioned that in the movie Don't Look Up, if some of them
Yeah.
have seen Don't Look Up, it is actually what is proposed to the president by her friend, the billionaire. He actually tells her, the story is about astronomers detect an asteroid which is going to come and hit the Earth in 6 months. And they report it to the president. But the president's friend, who's a billionaire, he is very excited about it because he thinks, oh, let the asteroid come, then we can get all these, we can even make more money.
Yeah.
And so it is something which is possible, but how it's done is this thing. Yeah. So
Intentions
like
are
I told you,
important.
some of this space business thing is very futuristic, science fiction-y type, but some of it
Exactly.
has actually been happening. SpaceX is on for so many years,
Yeah.
10, 15 years. They're actually doing business. So it's not in the future. They're already doing
They
business.
are already
So
doing it. Like many of
yeah,
the projects are
yeah.
already like space tourism. If you're talking
Yeah,
of
yeah. It's
the
like 20
launches of,
years old projects, 20, 30. I mean, it's very much on.
we just need to pay that amount if you are willing to go to have a round of space.
Yeah, yeah. So you have that lady who's going today, right?
Yeah.
What is her name? I forgot. But yeah, she's a
Uh,
Pakistani lady who's going today.
Pakistani lady. Yeah.
Yeah.
From the Middle East. Middle East. No, no, from uh, Dubai or Pakistan only. Pakistan.
Yeah, she's Pakistani, but she lives in Dubai.
Okay. Okay. Yeah.
So she's Pakistani origin, but lives in Dubai. And so she has paid the ticket and all that. Yes.
Arohi
I can
wants
see
to
another
know,
question from Arohi Gupta.
uh,
Yeah,
ma'am,
what are the goals of
what are the
Gaganyaan? So the
other
goals of
goals of
Gaganyaan is basically manned mission. Or the other
other
goals,
goals?
I think the basic primary goal is crewed mission, that we have to be able to send a man in space, because Rakesh Sharma was actually just sent by the Soyuz. They were sent by the Russians. This is something which we want to do indigenously by ISRO itself, right? But they are anyway taking help from the Russians, because since we do not have experience, see, sending humans to space is very risky business, because there is a life involved. So if there's a loss of life, if there is a disaster, right, then it is something which is very, very serious, right? If you have a space mission where the whole space mission burns off without any loss of life, that's okay. Still, it's okay. But if there are humans on it, then it becomes a much more ethical problem, you know. And therefore, crewed mission is something very, very crucial. That can you risk somebody going? So actually, I did not mention it, but for example, all the three examples, whether it was Elon Musk, Jeff Bezos, or Richard Branson, if you see when they did the space tourism thing, they were trying out space tourism. What they did is on the first flight, all of them went themselves, right? Because the biggest problem in space flight is security, safety. So people will say, will I go on such a mission? I mean, am I going to come back alive or no? And therefore, the best assurance these people could give others is like, see, I am going myself, right? Richard Branson himself is going on it. So he'll tell you that, I risked my life on Virgin Galactic. So why don't, I mean, you can also do that. So their biggest surety to people, to give them confidence about the safety of the mission, was by going there themselves, right? Now, so like I said, that's what I'm saying, that the biggest risk is crewed missions. And therefore, Gaganyaan, I would say the primary focus is still sending a crewed mission. The other thing is that how do you sustain them? What are the effects they have? How do you how long can they stay. All those are other experiments which will happen with the crewed mission. But that's the basic focus
basic
for
focus.
Gaganyaan.
Ishan again wants to know, ma'am, how do we see the industry luring the general population's interest, especially in developing countries like India? Because sectors like tourism are affordable only a margin of the population.
Yeah. So I would basically say that, see, how many customers do these people need, right? They do not need too many customers. And I'm
Yes,
sure on your fingertips, you can count at least five people in India who can afford that kind of a ticket. I won't take names, but there are people, right, in India. So
yes,
we do have the super rich, which has, the bulk of the money. And so you don't need to, this doesn't have to go for the masses. Only a few people have to buy that ticket. You don't need everybody to buy that ticket. So for that, it's fine. Yeah.
I think also it kind of a show that the capabilities we have in India, rather than
Yeah, that's right.
showing the masses the number
That's
of
right. Yeah.
people sending to the.
Yeah. So you're not going to send everybody. You're just going to send a select few. And only a select few have that kind of money, which is fine. So that's good.
I think, ma'am, with this, we'll wrap today's discussion. And
Yeah.
today's session was a little interesting in terms of, because we are not talking about the astronomy in terms of we generally do it on our platforms, but today with the broader perspective, like what are the new developments are taking place in country, and how the future, what is the future basically of, if we talk about the space science and technology. And the purpose of the Space Week is that only, to spread the awareness and to get a little understanding about the universe and science and technology in totality. So
That's right.
thank you so much for taking your time to talk on this a little off to the astronomy topic, but
Yeah. I was also a
really
little
thank
nervous,
you.
but that's okay.
Yes,
Yes.
yes,
Yeah.
I really specifically want to thank you for taking this opportunity for us, and always saying yes to Nehru Planetarium for whatever we come
Sure.
up with the ideas to say. So thank you so much, ma'am, for sharing this and for your
Yeah.
time. Everything. So I think we'll
Thank you
will.
so much.
Uh,
Thanks for having me over. Yeah.
yes, definitely
Bye bye.
will be planning more session on latest update related to space science, technology, and
Sure.
astronomy in the coming futures. Thank you, everyone. Thank you for joining, for giving your time to attending this session. Have a nice
Bye
day.
bye.
Bye. Take care.